Well, good evening, everybody, and thank you for coming out this evening. If we open our Bibles and look at the first pages of the Scriptures, we have in chapters 1 and 2 of Genesis a description of God's creative work in creating the heavens and the earth. And if we are to believe what God says, then we must accept what God says here, that he created the heavens and the earth. Now, I understand that that flies against the accepted wisdom of many, many people in this country and indeed in this world. But the Bible asks us to make a choice. Do we believe God or do we believe men and women? And if you just turn to that psalm that we read together, this psalm and many other places in the Bible portray God as being a being that is far wiser and far more knowledgeable than we are. So if you think of even if the wisest person that you know, then God is an order of magnitude wiser and has greater knowledge than that person. And so he says, doesn't he, in verse 7, when they say the Lord shall not see, neither the God of Jacob regard it, understand ye brutish among the people, and ye fools, when will ye be wise? He that planted the ear, shall he not hear? And he that formed the eye, shall he not see? What God's saying there is, well, people think I can't see what's going on because they can't see me. So they say, well, God doesn't exist because I can't see direct evidence that God is there. But God says, well, I'm far superior to you. I formed the eye. I formed the ear. Look at that and understand that my knowledge and my understanding is far away greater than anything you can do. And therefore, the fact that I can see from the heavens what goes on shouldn't be a surprise to you. So we're going to look at the subject of the eye. We're going to look at the wonder of a little tiny bit of the eye. We haven't got time to look at everything that I could tell you about the eye. First of all, we're going to look at the capabilities of the eye, just to set the scene, really, as to what a wonderful and magnificent thing this is, the human eye. Then we're going to listen to some comments that people have made on the eye, see what some evolutionists say, see what some creationists say about the eye. And then we're going to look at a little bit of the eye for ourselves. So that will unfortunately turn into a bit of a biology lesson. I apologize for that, but I find it interesting, and I'm sure some of you at least will as well. And then we'll draw some conclusions. So the eye is capable of distinguishing 40 million different colours. Now, that is a staggering number of colours. And you could ask yourself, if you believe that everything that developed in the human body was there for a reason to allow the human being to be able to do something better, we could ask ourselves, well, what gain is there being able to see 40 million colours? Surely wouldn't 20 million colours be okay? Or maybe just 10 million? Why would the eye be able to see 40 million colours if all it was about was the survival of the fittest? Do you survive better because you can see 40 million colours compared to 10 million? Is it worth the overhead and the energy it takes to be able to see all those colours? Well, of course, if you are a creationist, if you believe that God created a wonderful earth and that he wanted those that he created in it to share the joy of the beauty of what he had made. Maybe the iridescence of the creatures, the animals and the birds, or maybe the flowers and the complexity and the detail of the flowers. Well, maybe then it does make sense to have an eye that can see 40 million colours and not a million or 10 million. You see, if we see the eye as something that is allowing God's creation to see around them, then we perhaps look at it a different way. Now, the eye is amazing. You can go out on a hot summer's day when the sun is blazing down, and your eye will cope with that. Maybe you'd like to have sunglasses, but the eye, in its natural form, will cope with the brightness of that light. You can take that same eye, and you can go into a dark place, a dark sky, maybe a moonless night, and that same eye can see a single candle 3.5 miles away. And that is amazing in terms of the range of light that the eye can handle. If you had a modern camera, you couldn't do that. If we keep our camera analogy going for a little while, the scientists estimate that the resolution, as it were, of the human eye is about 126 million pixels. But the field of view is much bigger than you would get from a camera, 120 degrees. You've got a much, much wider visual field of view. The eye can process, they say, 100 frames a minute per second, so you can see things that move fast because the eye is able to see the small changes. You can resolve lines at 0.35 millimeters at a meter distance, which might not mean a lot, but it means that if you've got good eyesight, you can have a sheet of paper that's got lines 0.35 mil apart, and at a meter you can tell the difference between those lines. You can see the separation, which is an amazing capability. It is said that if you just take a look around the room quickly, the amount of information that is coming into the eye and has to be processed by the brain is more than a supercomputer. But that comes at a cost. The eye requires 3 times more oxygen than the cerebral cortex, and it actually consumes 20% of the total oxygen supply of your body. And it actually consumes 25% of the total glucose supply of your body. So your eyes are taking a lot of energy. And if you're going to think about it from an evolutionary point of view, is it worth having all that energy to see as wonderfully as we can? But of course, if we want to see God's creation, then it's certainly worth it. So here is the eye. I hope nobody's squeamish. But we've got, I think we'll be fairly familiar with this. We've got the pupil and the cornea at the front and the lens. And then at the back, we've got the optic nerve. And we're going to just look at a very small bit of the eye. This is the trouble with recording it because it doesn't work properly. Okay, so we're going to, it doesn't, the bill's not working. We're going to look at the choroid and the retina, which is at, you can see right at the very back of the eye. So if we sort of magnify what we're going to look at, we're going to look at that little tiny black square of the side of the eye. And we're going to have a look at all these things that are in the square or the rectangular image on the right-hand side of the image there. But we're going to come back to that in a moment, because we're going to just say, why are we talking about the eye? The eye challenges what the evolutionist would tell us needs to take place. The evolutionists will say that things develop slowly, step by step, and each step along the way has to have a benefit of it, on its own. The body's not going to devote resources to something that has no benefit to it at all. But when you look at the eye, you see that the eye is so complicated, it's hard to see how those things could have built up step by step. You see, imagine that by chance the eye had all formed all on its own, but somehow the optic nerve wasn't there. It would all be a terrible waste because the information couldn't go anywhere. It needs all of the little elements that we're going to talk about tonight, all to be in place before it functions. And so the eye challenges this idea, and the creationists call this irreducible complexity. The idea that you have to have all the parts before any of the parts work. Now, the eye is conversely held up by evolutionists as an example of what they call a bad design. Such a terrible thing that no designer would ever design an eye like that because it's such a mess. We're going to see what they say, and we're going to see whether we think that is actually a rational thing for them to say. And the last reason we're going to look at the eye is it's because of the few parts of the body that God directly says, I created that. We read it together, didn't we, in that psalm. God said he created the ear and he created the eye. So God is laying claim to this. So we know what evolution talks about. It talks about descent with modification. It talks about the fact that these things have to be step by step, a little bit of benefit each time, and that gets passed on. And they would say things get built up from simpler things to more complex things. When we've finished looking at the eye, I think you'll perhaps agree with me that there are things that are so complicated that we couldn't see design, or we couldn't see blind chance having any pathway of creating them. But as we said, irreducible complexity challenges that and says that you can't do that. You take any of those single parts out, then the whole eye or the whole organ doesn't function. You need everything before it'll work. But evolutionists say that this is a badly designed thing. Graham Phillips says no engineer worth his salt would design an eyeball the way ours has been built. And Richard Dawkins, the famous evolutionist, says any engineer would naturally assume that the photocells would point towards the light with their wires leading backwards towards the brain. And then he goes on to say each photocell is in effect wired backwards with the wires sticking out on the side nearest the light. So what Richard Dawkins is saying is if you were designing an eye, you wouldn't design it the way ours has been made. And what's he talking about? Well, there are two sorts of retina that you find in eyes. You find a verted retina and you find an inverted retina. So the verted retina, which you can see on the left-hand side, has the photosensors at the front nearest the eye, and the wires or the nerves go out at the back. And you can see what Dawkins is talking about. That seems to be a logical way of sort of designing an eye, to have the wires at the back, not at the front. Our eyes, and sort of most mammals' eyes, are inverted retinas. So the wires or the nerves go out at the front of the eye, which Dawkins calls a backwards wiring. But in actual fact, there are good reasons why the eye has been designed as it is. Now, this Dr. George Marshall, he's an eye researcher, he's a creationist, and he works at Glasgow University. And he was asked about this, and he said, well, the notion that the eye is wired backwards occurred to me as a 13-year-old when I was studying eye anatomy at school. It took me 2 years of lecturing on human eye anatomy to realize why the eye is wired the way it is. The idea that the eye is wired backwards comes from a lack of knowledge of eye function and anatomy. And that's what we're going to look at, the reasons why the eye is designed as it is and the benefits that the eye provides in having this design. But before we get into the detail, just a couple of things to think about. First of all, light is radiation, and radiation is harmful. So if we expose things to the light, then they are damaged. So if we have fabrics and we expose them to the light, they will fade. And it is the same with the eye. The eye is damaged by its exposure to the light. We also know that if we focus light, then the energy is concentrated in a particular point. And that again is what the eyes do. They focus the light at the back of the eye. And that means that that energy, that radiation, is being concentrated at the back of the eye. And the other thing that we would note is that the eye needs to perform over many, many years. The average lifespan is 70 years, then we want our eyes to last at least that long. So let's look back at our little sort of rectangle of squiggles and lines that we saw earlier. This is the neurosensory retina. And we're going to work our way down from the top, where the light is coming in, down to the cones at the bottom, where the actual detection of the light takes place. Because this is what Dawkins is talking about when he talks about it's all wired backwards. And if you look at that diagram, you can see his point in a sense that you've got all of this in front of the cones and the rods at the bottom, and surely that's going to have a negative effect. Well, we know from our experience actually using our eyes that it works pretty well as it's been designed. These areas actually, what looks like those big thick lines on the diagram, are actually virtually transparent to light. So they're letting almost all of the light through. But that wiring actually serves a function. It reduces the distortion of the scattering of the light. So, you know, if you're on a bright sunny day or you've got lots of lights in front of you, you might put your hand up to your eyes to stop that sort of scattered light entering the eye. Well, that actually is what happens inside the eye. As the light comes in, it is channeled through that wiring to remove the sort of the bouncing scattering light and to just bring in the light that is coming directly from the source. But in actual fact, there is something else that's within that wiring that negates any issues that you might have from that wiring being in front of the rods and the cones. These Muller cells are little fiber optic tubes that sit above each of the cones. And they're tuned to whichever color the cone is actually sensing. And they bring the light and in the path down to the top of each of the cones. So any problem that you might have with wiring in front of it is immediately negated because the light is channeled down to where it's needed. And you can see at the very top, the Muller cell funnels outwards so it can gather more light. So if we actually look at these wires that are in front, they're much more than just wires that transmit the signals. In actual fact, the optic nerve is right at the very top, taking the information away back to the brain. But in that wiring, you've got these things called ganglion cells, or a ganglion layer. Now, these are actually mini brains all on their own. These do what's called edge extraction. So they process information from the cones down at the bottom before it goes onto the optic nerve and actually interpret what is being seen before it's sent to the brain. This has been a mystery to many scientists for a long time. How does the optic nerve transmit all of the information that the eye is capturing? And the answer is it doesn't transmit it all because it's actually processed in the eye, and then that information is then passed through. So there's 12 different types of ganglion cell, and they are all specialized in doing different things. So one sort of ganglion cell will do like a line drawing, an outline of what's being looked at. Other ones are focused on movement, so just picking up movement from one area to another. Others are just focused on highlights or shadows. So that in the eye itself, the information is processed before ever it gets to the brain itself. And so that is an amazing and wonderful thing. And you think, well, if you're thinking about bit by bit sort of development of an eye, then how did these ganglion cells know that there was some information that it could pick up from the cones? And how did it know there was a brain to send that information to? And how did it know what sort of language to use to send it across to the brain so that it could interpret it? You see, it all has to work together or it doesn't work at all. So let's go down to now the rods and the cones. There's about 126 million rods and cones, which is why they talk about 126 megapixels in your eyesight. The rods are for night vision, so they're specialized on lower light, but without the color. And then you've got 3 different types of cones, one for each of the primary colors. But the cones have pigments in them that pick up that particular light color. And they're bleached by the light. So as the light's hitting them, they're being damaged. And so they have to be constantly renewed. So the waste material from the cones has to be taken away and new material has to be brought in to replace it and keep your eyesight still working properly. And that's the reason why they're nestled right down at the very bottom, the very back of the eye, because they need to be in contact with the choroid area, which is the area right at the very bottom. That's got a massive blood flow, and that blood flow increases when light levels increase. So it cools the back of the eye. So as you're getting more light in there, more light energy and more radiation into your eye, then the blood flow speeds up so that your eye is cooled. But it's also bringing in that oxygen for the eye to function, because as we said, it takes 20% of your oxygen to run the eyes. And it also then works as a transmission to take away the waste products and to bring in the new chemicals that are needed for the cones and for the maintenance of the eye. So you can see what complexity there is just in this very tiny bit of the eye. Now, Richard Dawkins said that he didn't think the human eye was very well designed. But in actual fact, if we followed his logic and said, well, let's design it with a verted retina instead of an inverted retina, then actually we wouldn't have a very good eye at all. It would be quickly damaged because you're not in contact with the blood flow at the back that can bring in those new chemicals and can keep the eye cooled by the blood flow. So your color perception would deteriorate rapidly as you aged. Because you haven't got the wires in front, then your color perception isn't going to be so good. You're going to have lots of scattered light in your eyes, and it's going to provide distortion. And of course, don't go out on a hot sunny day because your eyes will overheat and then they're not going to function at all. In actual fact, it's quite interesting that the verted retina that Dawkins thinks is so much better is often found on sea creatures under the water where they have very little light. And therefore it makes sense that they need to maximize the minute amount of light that they have. And therefore you wouldn't want the wires, as it were, getting in the way. And you wouldn't need to worry so much about cooling the eye because there's not much light for it to see. So we've seen, when we've looked at the eye, amazing design. And we've only just looked at one very small part of the eye. But what does the psalmist say? Well, in Psalm 139, the psalmist speaks of God's creative power. And so he says in verse 13, "For thou hast possessed my reins, thou hast covered me in my mother's womb. I will praise thee, for I am fearfully and wonderfully made. Marvelous are thy works, that my soul knoweth right well. My substance was not hid from thee, when I was made in secret and curiously wrought in the lowest parts of the earth. Thine eyes did see my substance, yet being imperfect, and in thy book all my members were written, which in continuance were fashioned, when as yet there was none of them." What the psalmist is saying is, when he looks at the complexity of life, and he's looking back to and thinking about what happens in the womb, and it's thinking about the development of the human body, he can only stand in awe and say, God who created this is far beyond my understanding. Now, we know an awful lot more about the complexity of the body than the psalmist David knew. And yet, the more we delve into the body, into the eye, the more we see astounding complexity. And we can ask ourselves, could that have come by chance? Could it just randomly have developed all of these things? Could there be all these interconnections between the brain and the eye, and within the eye, the different parts working together harmoniously? Could all of that just come by chance to devise the capabilities we have? You see, I could talk to you about the eyelid. I could tell you how amazing the structure of the eyelid is, that it keeps itself in contact with the eyeball. I could tell you about the cornea and tell you that the cornea takes its oxygen directly from the air because it's exposed to the air. But of course, when you go to sleep, it can't take the oxygen from the air. And so there has to be a method inside the eyelid that provides oxygen to the eye when you're asleep. I could talk to you about tears. The structure and the substance of the tears is such that it will sit and cling to the surface of the eye. It has to be a special consistency, otherwise it would all pour off. And I could tell you that actually the cornea and the tears do most of the focusing. We have a lens, and that does some of the fine focusing, but 80% of the focusing of the eye is actually done by the shape of the cornea, and the tears providing a refractive index between the two. I could tell you about xanthophyll pigment. That's a very, very specialist pigment that just picks up the radiation that's outside our visual range of what we see, that isn't captured, that isn't prevented from entering into the eye. And somehow in the eye there is this pigment that picks up a specific wavelength of light that is harmful and is of no benefit at all to the seeing of the eye, because we don't see in ultraviolet. Somehow that chemical got there, and somehow it's of use to the eye to preserve it. But the more I look at the eye, the more I'm amazed at its complexity. And the more I look at the human body, the more amazed I am at its complexity. And the more I look at the world around us and the complexity of plant life and animal life and the interaction between the two, I'm amazed at the complexity. And for me, I cannot see how that could come by chance. It has to be the hand of a designer. And so we all have to ask ourselves, who are we going to believe? Are we going to believe men and women who say, no, it all came by chance? There's no need to worship a God. Or are we going to believe the Creator himself, who says, well, I made you as you are, but I also call upon you to worship me. And what did he say in Psalm 94? Understand ye brutish among the people, and ye fools, when will ye be wise? You see, God's wisdom is different from man's wisdom. God's wisdom centers around us believing what he says and acting upon it. And so he says, as we read, doesn't he? He that planted the ear shall he not hear, and he that formed the eye shall he not see. You see, God sees what we do. And the other thing that the evolutionists cannot offer is any hope. According to them, we live our life, and it doesn't matter how terrible that might be. At the end, we die, and that's it. There is no hope. There is no life beyond the grave, according to the evolutionists. And yet God says, for those that trust in him, for those that will follow after him, eye has not seen, nor ear heard, neither hath entered into the heart of man the things which God hath prepared for them that love him. So I appeal to you tonight to think about these things, to think about whether God created us and designed us to be fearfully and wonderfully made, and therefore is a God that should be worshipped, or whether all of this complexity just comes about by chance, in which case we might as well just shut the book and walk out the door and enjoy ourselves until we die. God gives us a choice, but he's also given us many reasons to believe in him, and the complexity of creation is one of them.